Hello everyone, and welcome to today's webinar on the REMLIVE Liveline Indicators. My name is Kumail Saeed, and I am one of today's presenters for this webinar. Just a bit about myself. I am a product manager at NHP, responsible for the connectivity, control, and signaling portfolios, and have a background in electrical and electronic engineering, having graduated with a Bachelor of Engineering degree from the Auckland University of Technology. My co-presenter today is John Rollison, who I will pass over to introduce himself.
Thanks, Kumail. Hi, everybody. I'm the Managing Director of REMLIVE, and we are the Electrical Safety Warning Indicator Specialists. I also have a background and a degree in electrical engineering, and I'm currently a member of the IET. Prior to REMLIVE, I spent 20 years working for various US tech companies, and I'm actually based in the UK. Thank you so much for inviting me to join the webinar today.
Thanks, John. Just before we proceed further with the webinar, a reminder that if you have any questions, you can leave them in the chat box. We will address the questions towards the end of the webinar. So here is the agenda for today's session. We'll look at general electrical safety in the workplace and risks that users are exposed to, an introduction to the REMLIVE Liveline indicators, including an overview of how it works, its basic construction, and how it's used to improve personal safety in the workplace. How the REMLIVE product is used in the electrical isolation verification process. We'll look at the features of the product in more depth and the various benefits to the user. With the introduction of a new model of the REMLIVE Liveline indicator, now available in Australia and New Zealand, we'll provide an overview on the modifications, reasons for selecting the REMLIVE product for your application, and then finally, we'll cover off on some of the resources you can make use of. I'll pass over to John to discuss electrical safety.
Thanks, Kumail. Electrical safety in the workplace is obviously a really critical topic. Statistics from Safe Work Australia, based on some research they did between 2003 and 2015, showed that 142 workers died in Australia as a result of contact with electricity, which is sadly an average of 11 workers each calendar year. An example, back in 2002, Queensland Mines Inspectorate issued an alert after a plant operator in a mine in Queensland isolated an energy source to a pug mill just to carry out a daily cleaning task. Unexpectedly, the pug mill started up, and the reason was that an internal aluminium shaft inside an isolator had broken and allowed the handle of the switch to rotate to the off position without actually isolating the energy source. So the isolation was ineffective, and then the equipment obviously is inherently unsafe. Another report by the Australian Institute of Health and Welfare found that most electric shocks happened within the workplace. That was between 2014 and 2016. And only last week, actually, Safe Work South Australia announced that their inspectors will target electrical safety in a statewide crackdown as part of a campaign to reduce the risk of electric shocks in the workplace. And this is because in 2021-2022, Safe Work South Australia issued 239 statutory notices associated with electrical risks across all industries, up 26% on the previous year. Nearly 3 in every 4 statutory notices issued related to a failure by an employer to regularly inspect and test their electrical equipment. REMLIVE devices are used in more than 40 countries, and the guidance from virtually every health and safety executive we work with is similar, that it should never be assumed that equipment is dead while work is being carried out. So additional testing is always required. Kumail is going to explain a bit more about how REMLIVE can improve electrical safety procedures and lower your risks later in this webinar. Virtually every workplace exposes workers to the dangers of electricity in some way. In our experience, and in talking with experienced HSE inspectors around the world, electrical safety incidents fall typically into 3 broad categories: electrical generation, transmission and distribution, low voltage fixed installations, and electrical equipment and machinery. So if we take a look at electrical supply incidents, they are typically connected with non-compliance with safe systems of works. This can lead to shock, burns, fires, and in some cases even explosions. Low voltage incidents are mainly to do with a failure to isolate and again, or non-compliance with the approved procedures, again, leading to shocks, burns, falls, and all sorts of other nasty incidents. The third is equipment and machinery incidents. They tend to happen because of poor maintenance and non-compliance with procedures, yet again. Unexpected startups can be particularly nasty and happen because of poor interlocks, non-compliance, and can often lead to very serious injuries and deaths. REMLIVE products were designed really to reduce the risks and save lives in low voltage installations, and of course to help prevent incidents with electrical machinery. This slide shows a variety of electrical safety warning signs. Every workplace has signs like these almost everywhere, but really the question to ask is it really enough? I mean, when was the last time you saw one of these signs and really thought about the risks electricity brings to your workplace? I mean, it's worth remembering that as little as 24 volts is enough to kill a human being, and it can happen in a split second. So again, REMLIVE is all about lowering the risk of electrical safety incidents by providing a permanent and live reminder of the presence of electricity. We often get asked, where should I fit REMLIVE warning indicators? And of course the answer varies depending on the application, the risks and the workplace. Generally, we find people fit REMLIVE warning indicators where risks are higher than average across any organisation. And so, when you're thinking about it, questions like, what is the level of electrical awareness? How complex is the machine or environment? Does the application include remote working? Is the pressure and cost of downtime high? And do you have, a high workforce turnover, contractors in your organization, for example? Also, you might want to consider the age of your equipment. Risks always increase with older systems, and also the frequency of contact that someone may have within a live electrical system across one site or across many sites. The idea for REMLIVE warning indicators came after a fatal incident at a steelworks in Wales back in the late 1990s. We've worked with our partners and customers ever since to provide a simple and reliable way to show that an electrical circuit is live. REMLIVE liveline indicators provide that visual reminder to an operator or user that the circuit is live and can be used to observe the change in state when our LEDs on the display go from on to off. And that's when the isolator device is typically switched to off. If there's a problem, then REMLIVE can detect it. And as a result, this can help reduce the risk of accidents to the operator user and, importantly, potentially save lives. At least it's going to reduce the risk of accidents. The REMLIVE display unit indicates individual phase voltages on three-phase A systems as well as the neutral. And this status information can be used to assist in identifying where those dangerous voltage levels are, even after isolation has occurred if there's a problem like we heard about in the example earlier. So REMLIVE products have been keeping the workplace safe for over a decade in Australia and New Zealand, and today we have a large installed base across many sites across both Australia and New Zealand, actually in around 40 countries around the world, and that includes many of the major Australian mine sites that I'm sure you'll all be familiar with. The liveline indicator has gone on extensive relevant testing to ensure it meets the required standards, and this includes meeting RCM compliance and all of the global standards that we need in terms of overvoltage categories, insulation testing and various others, and we're going to look at that in some more detail later in the presentation. We're incredibly proud to have partnered with NHP for more than 11 years now. NHP are our exclusive partners for both Australia and New Zealand, a relationship we have both recently recommitted to. We often work very closely together to help solve customers' application challenges, and actually we've also developed our products based directly on NHP's customers' requirements and feedback, as we will share more about as we go through the webinar today.
Thanks, John. NHP and REMLIVE have a strong relationship and has been so for over a decade. We collaborate heavily on product development, taking into account what's relevant for our customer base in both Australia and New Zealand. We review the relevant standards to which the product needs to be tested to, that it has all the relevant certification, and also to ensure that we provide the right level of support to our base, which includes technical and application support. The REMLIVE Lifeline indicator is ordered using a single part number. This used to be RL24I, but now with the upgraded model available, the new part number is RL24IC. More on this point a bit later in the webinar. When you order this REMLIVE part number, you get three components which are pre-supplied and used together to give you the complete Lifeline indication solution. This includes the DIN rail mount monitoring unit, also known as the base unit. Then there is the display unit and a RJ45 cable used to connect the monitoring unit together with the display. The monitoring unit is mounted to DIN rail inside a switchboard or control panel and has a standard 22.5mm width size. This unit is typically connected at the load side of the isolating device. The display unit includes LEDs to indicate the live voltage status and is designed to fit through the front of a control panel or switchboard so that the operator can clearly view the voltage presence status. And then finally, the RJ45 cable, which is used to connect the monitoring unit with the display. The cable is pre-supplied in a 1.5 meter length size. The REMLIVE Lifeline indicator covers a wide range of applications with just this single model or part. We'll look into its features in more depth to appreciate this point more. Let's look at the components in more depth, including some of the features that they have. As mentioned before, the monitoring base unit is mounted to DIN rail and located inside the switchboard or control. It monitors the voltage of the circuit it's wired to, with the new REMLIVE model able to monitor voltages from 24 to 1000 volts. More on the ratings a bit later in the presentation. For the circuit being monitored, if voltage is detected between any two conductors in the specified range, then this unit outputs this to the display and the LEDs on the display light up. The unit includes a RJ45 port located at the front of the unit. It's circled as you can see on the slide. This port connects the RJ45 cable, which is already pre-supplied when you order the REMLIVE Lifeline indicator. The monitoring unit also includes dip switches located at the side of the unit. These switches are used to control the flash mode of the two banks of LEDs at either side of the door display unit, which indicates as soon as the REMLIVE monitoring base unit detects the minimum specified potential difference between any two connected conductors. The LED flash modes are on steady, on flashing, or off altogether. The position of the dip switches for each mode is represented on the label found on the side of the product, and I've circled this for your reference. The unit has a standard size that you would expect of an electrical component used inside a panel or a switchboard. Its dimensions read as 100mm high, 122mm in length, and 22.5mm in width. Then we have the display unit. This is mounted by creating a 30.5mm circular hole on the front panel and is secured by the locking nuts which are pre-supplied with it. And the surface area of the display unit measures 41mm in diameter. As you can see from the image, the display unit makes use of fairly bright LEDs designed to capture the user's attention on the presence of live voltage. Each phase is represented, that's L1, L2, and L3, as well as neutral, so that the operator is provided info on potential difference between the various conductors being monitored. Each of the phases is represented by dual redundant LEDs, although the LEDs used have a long lifespan and overall reliable quality. In case of failure, there is an LED for backup for each of the three phases. As mentioned in the previous slide, the two banks of LEDs located on opposite ends of the display unit, and I've highlighted their positions on the image on the slide as well, will always indicate if voltage between any two connected conductors is greater than the minimum specified voltage level that the unit can monitor. When set to flashing mode on the monitoring unit, which is what we looked at in the previous slide, the LEDs located on the sides maintain a consistent 1-second flash rate if live voltage is detected. Similar to the monitoring unit, the display unit also includes a RJ45 port, which is located right at the back of the unit. It's used to connect the RJ45 cable and establish that connection to the monitoring base unit. It's worth mentioning that this display unit is electrically isolated from the base monitoring unit, which monitors voltages from 24 to 1000 volts, and so the user is protected from such dangerous voltage levels interfacing with the display. Display unit has a extra low voltage value of 3.8 volts DC. Therefore, even if the user comes into direct contact with the display, they will be safe and not succumb to it. And for the final point, the display unit has a IP66 rating, making it suitable for use with various panel boards, modular switchboards, and so why do we actually need liveline indicators, and how does it improve personnel safety for operators servicing live boards? For this, it's worth reviewing the general electrical isolation process and the dangers this presents to the operator. Now, say you have a distribution board which is supplying multiple sub-circuits connected to loads. The service technician needs to perform maintenance, and hence they need to isolate the power source or sources to the loads in order to replace components as part of the maintenance function. When the isolating switch or circuit breaker is turned off, you can still have dangerous voltage levels present in the circuit. Coming into contact with can be fatal. Why is there still dangerous voltage levels present despite isolation being performed? This could be due to a number of reasons. It could be due to stored energy feedback in the circuit. It could be because all power sources have not been correctly identified and isolated. It could also be that the isolation device itself has failed, and there are documented instances of this happening, and so energy is still supplied to the load. The bottom line here is that even if a isolating device is switched off, it's still not safe for the operator to presume that they can make direct contact with component service. Now, this is where the REMLIVE unit can help assist the service technician. Say the REMLIVE unit is installed, wired, and available on the and the service technician switches off a load or loads using your isolating switches or circuit breakers. If there is still dangerous voltage levels present in the circuit, due to the reasons mentioned before, then the REMLIVE unit will indicate this to the user as the LEDs on the unit will turn on. The expectation then will be that the service technician takes further measures to identify reasons for why correct isolation has not occurred and address these issues. By acting upon this correctly, the user can expect the REMLIVE status LEDs to change state from on to off. Now, before the service technician assumes that correct isolation has occurred and they can work directly within the board now, it's recommended that they test the circuits using a multimeter to ensure it has indeed been safely isolated before carrying on with the lockout and tagout process. Let's look at some of the general steps taken during the electrical isolation process and how the REMLIVE liveline indicator is used. This by all means is not meant to be a complete guide on the electrical isolation procedure, just a summary of the general steps so that we can understand the use of the REMLIVE liveline indicator a bit. Now, before isolation, it's assumed, of course, that the REMLIVE monitoring and display units are installed and wired correctly to your panel. When the system or circuit is live, the REMLIVE display unit LEDs should be on. Right, so let's now assume that we have this panel on site, it's live, and the REMLIVE display unit is indicating as it should be to provide a visual indication to the operator that voltage is present. The panel needs to be serviced, and so the service technician is brought in, and before the technician can make any direct contact with electrical components inside the panel, they need to electrically isolate the panel or circuit. They first need to identify the correct isolation point or device for the main source of energy, isolation points for any secondary sources, example, any UPSs, standby generators, etc. They also need to be considered as part of this process, which is quite important. Once the correct isolation points or devices of the system have been identified, isolate by switching them off. Keeping an eye on the REMLIVE liveline indicator, check if the LEDs have changed state from on to off. If the LEDs have turned off, it indicates that there is an absence of voltage. However, don't yet make any contact with components inside the panel. It's required for the service technician to carry out further testing using a multimeter. It's important to note here that the REMLIVE liveline indicator is not used to bypass any safety procedures and instead provides an extra level of safety to the user as the live visual status is given on the presence or absence of. Another point to add is that measuring live voltage with a multimeter is a hazard on its own. By using the REMLIVE liveline indicator, it gives you an extra level of safety before you use your multimeter. Now, I did say at the start that these were general steps, to consider as part of the electrical isolation process. You need to check your country or state's standards on the complete electrical isolation procedure and ensure that they are followed. The status of the lifeline indicator should be monitored regularly throughout this process to ensure the safety of the operator. Once you've established electrical isolation, it's generally required to lock off the isolation device or devices, which was used to isolate relevant installation circuits. And then after that, warning or cautionary notes also generally need to be attached so that others in the facility are aware not to come into contact with the. Let's now look at the features of the REMLIVE unit in more depth, starting with the voltage monitoring range. We've already discussed how the REMLIVE DIN rail mount unit monitors the voltage level of the circuit. That's the circuit from the load side of a switching device and the actual load being switched. The latest update to the REMLIVE Lifeline unit can now monitor voltage ranges from 24 to 1000 volts DC and 26 to 1000 volts. The utilization voltage range of the REMLIVE unit is in compliance to the requirements of IEC 638-2012 standard. The tolerance limits of plus 10%, negative 11%, as indicated on the slider, are dictated by the standards and don't represent the actual limitation of the REMLIVE unit. Now, despite the wide voltage range that the unit can monitor, for where the unit will be installed in the distribution system, it's important to consider the overvoltage category, as this influences the monitoring voltage specification of the REMLIVE unit. As you can see on the slider, for overvoltage category 3 applications, the monitoring voltage range specification is 24 to 1000 volts AC and 26 to 1000 volts DC. This is whereas for Cat 4 applications, the monitoring voltage range specification is 24 to 690 volts AC and 26 to 600 volts DC. I'll go into more detail about overvoltage categories in the upcoming slide and why this should be considered as part of component equipment selection for an application. For three-phase AC systems, the REMLIVE product manual provides the relevant line to neutral and line to line readings for 690 volts and 1000 volt nominal voltage supply and the corresponding overvoltage category for which it's used in. Information is provided for DC voltage systems as well, and advice on the maximum voltage on a single conductor is also stated. All this information is provided in the REMLIVE installation sheet when you purchase the product. As mentioned in the previous slide, I wanted to speak about overvoltage categories as it's an important consideration to make, not only when selecting and installing the REMLIVE unit, but also generally other electrical equipment. Equipment that is installed and wired to high voltage supplies needs to have a suitable overvoltage withstand capability and in accordance to IEC specifications. Overvoltage transients on power lines can cause damage to connected equipment and as a result can also expose users to damage. There are four main overvoltage categories which have been defined and I will reference it to the diagram that you see on the slide. Cat 4 is the highest overvoltage category, which means that components and equipment are likely to experience high energy voltage transients at this point, especially in comparison to other equipment located in other overvoltage categories, as in comparison to Cat 4, which is installed directly at the utility side. The example on the diagram shows a utility grade transformer for which Cat 4 ratings apply. Other examples include service entrance boards, which includes components such as your surge protection devices, utility metering, isolators, and liveline indication devices, such as the REMLIVE unit. The Cat 3 overvoltage category applies to components inside a distribution board or panel, example fuses, isolating devices, circuit breakers, etc. The overvoltage transient levels seen by Cat 3 equipment are generally diminished in comparison to what is seen at the Cat 4 level. For most applications using liveline indicators, we see it being installed and used at this level, and therefore it's again important to highlight that the upgraded REMLIVE unit, that's the RL24IC, has a monitoring voltage range from 24 to 1000 volts at Cat 3. Cat 2 category is for equipment that's supplied from a fixed installation, example from the wall outlet that you can see in the diagram. Then we have Cat 1, which is the lowest overvoltage category. Measures are taken on such circuits to substantially and reliably reduce transient overvoltages to hazards to users. As per the AS/NZS 614391 relevant standards, for a system nominal voltage of 690 volts, the maximum rated impulse withstand voltage that the REMLIVE unit is tested for is 8 kV at 1.250 microsecond for Cat4 over. And similarly, for a system nominal voltage of 1000 volts, the maximum rated impulse withstand voltage that the REMLIVE unit is tested for is 8 kV at 1.250 microsecond for Cat3 overvoltage category. As per the table shown on the upper right-hand corner, the maximum impulse ratings are given between the various conductors, example line to earth, line to neutral, and line to line for your reference. This can also be found in the product installation manual supplied with the REMLIVE. Let's now look at how the REMLIVE unit is connected and the typical wiring configurations that it supports. As seen in the connection diagram, the REMLIVE unit's inputs are connected to the load side conductors of the isolating device to monitor the voltage levels in that 24 to 1000 volt AC and 26 to 1000 volt DC band. Therefore, when it detects voltage in that range, it illuminates the LEDs on the display unit to warn the operator of the presence of live voltage. For three-phase 4-wire systems, the neutral on the base unit is connected to the neutral conductor. And if you're using a three-phase 3-wire system that's with no neutral conductor, the neutral on the REMLIVE base unit can be connected to functional or dead. The use of a neutral conductor or earth connection is strongly the use of the REMLIVE liveline indicator. The table at the bottom of the slide shows the various connections that the REMLIVE unit supports, including DC and earth connections, single phase and earth or single phase with earth plus neutral. And then of course the three-phase 3 and 4-wire configurations that we. There are other features of the REMLIVE unit that should be highlighted. For example, the upgraded REMLIVE unit is compliant to the IEC 60204 standard on safety of machines with respect to insulation tests on electrical devices. Insulation resistance tests can be performed on the device if required. From the testing that was done before product release, the insulation resistance for the unit measured at greater than 20 megaohms. The instruction on conducting the insulation resistance tester on the device is described in the manual supplied with the product. We touched on this before when looking at the display unit. Worth highlighting again that this display unit has extra low voltage of 3.8 volts DC, which is safe for the user or operator in case they come into direct contact with it. The LED has a consistent flash rate of exactly 1 second. That's only the LEDs located on the sides of the REMLIVE display unit, example the ones without the phase and the neutral marking. And there is convenient separation between the various connection points on the REMLIVE unit, example the phase, earth, and neutral connection, to facilitate ease of wiring. We've covered in detail the features and overall function of the REMLIVE unit. Let's now go through some of the selection points that are considered before selecting a lifeline indicator. The first point to consider is that the distribution board or control panel facility and application will have a requirement to be serviced over time, which means a technician will come in and electrically isolate the panel and perform a full lockout tagout procedure. The liveline indicator will be useful to this isolation process, and we saw this before, and it protects personnel from shock if the right procedures are adopted. Other points which will be considered when selecting a liveline indicator: the voltage range that the unit can monitor. Remember, both the lower and the upper limits of the voltage are important to consider in terms of selection. Simplicity in terms of the setup and installation, and not only in the new panels, also for retrofitting. Overall reliable performance. It's important that the unit functions correctly and does what it's spec'd for, and that too over a long time period. It helps that a unit has undergone rigorous testing, which provides a high degree of confidence in it. You want it to be safe for the operator to use. Remember, you are working with dangerously high voltage levels. Therefore, that electrical isolation between the main monitoring unit and display unit is important. The REMLIVE liveline indicator, as a result, is used in a wide range of applications in the power distribution and industrial control space. They are installed in distribution boards, modular switchboards, and control. This makes the REMLIVE product relevant for use across many industries, including mining, manufacturing, power, water, wastewater, etc., to name a few. So what's new with the REMLIVE Lifeline Indicator? It was advised earlier that the REMLIVE product has undergone upgrades to the original model. So let's summarize some of these points as per the table shown, most of which we have already covered in detail. Number one, the extended voltage range that it monitors, which is now 24 to 1000 volts AC and 26 to 1000 volts DC. Lines to IEC 60204 for safety of machines for installation tests. Increased separation between connection points for wiring convenience. The new unit is backwards compatible with the older model, meaning it meets the same standards and can perform the same functions as the older model, and therefore can support existing applications for what they're used for. The NHP ordering part number has changed from RL24I to RL24IC, so just the introduction of C to the part number. This has been done so that we can maintain appropriate revision control. NHP does have a transition guide which has been developed that details the change and can be shared upon request to our sales team. We also have new packaging for the RL24IC unit, which comes in the bright yellow package, as shown on the slide. Apart from the product, this includes the product installation guide as well. So why select the REMLIVE Lifeline Indicator? With its use in the isolation verification process, the REMLIVE Lifeline Indicator can help prevent electrical accidents from occurring and ultimately saves lives. It supports a wide range of applications as a single device type. We covered before the various wiring configurations that it has, and its ability now to monitor voltages up to AV. The components included for this product easily connect together and are very simple to install on the panel. Once it doesn't require any ongoing maintenance. Again, only 3.8 volts DC to the display unit. It's undergone rigorous testing to ensure reliable performance and that it meets the relevant standards. We've covered in this presentation examples of the overvoltage categories, insulation testing, etc. NHP has been supplying this product for over 11 years, and therefore we are quite familiar with the product applications and can provide further localized support for our customers. We will continue to do so for our expanding customer base. Different resources have been developed for your reference to support technical and application requirements. There's the installation guide, which is supplied with the product. It includes info on the product ratings, correct setup, dimensional diagrams, etc. A transition guide which details some of the differences between the upgraded has also been developed and can be shared upon request. There's the product flyer as shown on the slide, which includes basic information on the product, description of its use, reference to the single ordering part number, and tech info, etc. Remember, you can always contact NHP for any application tech questions or general queries that you may have, and we will be more than happy to support. This now brings us to the end of the presentation section of the webinar. Next, we will go through questions. Everyone, thank you for your time in attending this webinar. We'll move on to the questions section. We've had some good responses. So one of the questions that came through was, what protection is recommended on the alarm? And the answer to this is that the REMLIVE unit has inbuilt fuses. So generally no additional protection is required. Lifeline indicator. We did have some other questions that we received as well. That will require a bit more discussion with respect to the application. But yeah, look, that really brings us to the end of this webinar. Just time in attending this webinar. If you do have any further questions, please feel free out, and we will also reach out to some of the questions that were. Yeah, look, thank you again for your time.
Thanks, everybody.